today we'll be looking into some details on machine learning applied to communication systems. And basically, if we try to look at this topic very carefully, most of the communications what we are dealing right now, whether it is line or wireless, the next generation communication systems are heavily filled with machine learning algorithms. And why we are trying to do that is the data coming into the system is very heavy. Like for example, if you think like 50 billion devices are sending data to a server for compiling or to the cloud to compile it, it is not a small thing. And it is not possible for a small routines to run and check the data or not. And hence we move towards a machine handling the data sets. We are giving the data sets to machine to handle it and provide the information to us. For example, if you try to look into a fire sensors in the house, if a fire accident house, the data has to be picked up by the fire station and they have to report at the place and put off the fire. That's the scenario if you try to take. And in a locality of a small area like some colony, there will be a few thousand houses in it. And each house might have 3 to 4 rooms. And each room is equipped with a fire sensor. And you can see the data coming into the, and if each data sensor is sending around even 20 bits or 40 bits, you can see how many bits are coming into the fire station continuously. It is not they are sending periodically. If they try to send periodically, which means that every 5 minutes or 10 minutes, the time is sufficient for the damage to be caused by the fire. So every second they are trying to send the data, and that data the fire station has to check whether is there any fire or not, indicator or not, and discard that and take a new set every second and check all the data and throw it off and take the next set until they find some discrepancy and then try to look into it. And it is not possible by a human being because the data sets are so large and it cannot be handled by a human. It has to be handled by a machine. Hence, the data sets are very large, right? And if we try to look into the 6G communication, what we are trying to do, every segment is filled with machine learning. Every part of the communication system is provided with machine learning, right? Whether it is a receiver synchronization, it is there. Or channel estimation, machine learning is there. Equalization, ML is there. Symbol demapping, ML is there. Decoding, ML is there. Or if you look at transmitter, encoding, ML is there. Symbol mapping, ML is there. And modulation, ML is. Which means that every block in the communication systems are loaded with machine learning algorithms. And it is the order of the day that if we say that we are not into it, it means that you can see the questions over here, right? So if you take the classical 5G systems and if you are running into a 6G, it is heavily loaded with machine learning or deep learning algorithms, which will be handling it because the user densities are increasing, the information bits are increasing. Because when we try to move towards the 6G, the data rates are at terahertz and terabits per second or pentabits per second. It is no more megabits or gigabits, right? 10 to the power of 12, 10 to the power of 14, 10 to the power of 16, we are trying to reach that so many data bits are coming into the exchange and they have to process it. Either it is a mobile center or some center, it will come into that and they have to handle it and service the things at that speeds, right? So, no, sorry. Sorry? Machine learning. The machine learning is we are training the machine to handle such type of data. Sorry?
So that will be dynamic in nature. Every time we cover input with the chip, that is okay that
No, the machine learning we are giving it intelligence to handle such data. So the intelligence might be updated every day. Like for example, I'll tell you a simple example. So when we are in the first class, we are only taught 2 plus 2, 3 plus 3, 4 plus 4, single digit numbers. When we move to second class, we have been taught with 2-bit addition, 2-bit multiplication, 2-bit subtraction. And as we go on, when we come to plus 2 or plus 1, 11 and 12, we are taught integration, differentiation. And as we go along, we get number of mathematics involved in it. So like machine learning also, initially we train with a subset. And then as and when the demand comes, we increase the data sets to that, increase more and more power into the system so that they can do the job more efficiently, right? It is only a training set. If I know what is 2 plus 2, I can easily see if a number is there and given some addition or subtract, I can do it. So it is like a neurons which you are trying to train it and keep it so that when the data comes, it tries to look into the data and predict it. So these algorithms are, again, we have different types of algorithms which we have to look. So they are basically mathematical algorithms only, right? Am I clear? No, we write a code and keep it to the machine so that it executes. So like when we write a C code program, we say that this is the input and this is the corresponding result what we get. So the result, the input what you are giving, you are typing some numbers or some file name or something, image or something, and you get the result out of it. So the machine learning also, we train the machine with some code, and we give the input data and ask for the result. So we have a lab session after this class where we give you some training on popular machine learning algorithms. We have 5 or 6 algorithms. I think 5 algorithms or 3 algorithms. We train you with 3 algorithms. Rest, I think you can easily do it. Once you are trained for 2 or 3, then rest of the algorithms you can do it. So we'll write a code for 3 algorithms. We run it, and we train the algorithm with some data set, and we'll ask them, if this data comes, what is the outcome, right? After this class, we'll try to do the lab session on that, okay? So when we try to look from the data point of view, so if we assume that today we have $80 billion 80 billion devices connected to the network, or 50 billion devices are connected, and next to 2 years we might get 80 billion. So you can see that the data, what it is coming, everywhere you will see data on, zeros and ones only, right? And so much data is unable to be done by your laptop or your desktop and all. We need a huge memory for holding it and then do processing on it, right? So you see the complexity of the problem. It is, for time being, what we try to do is, since we are seeing one drone, we might not have so many. But if multiple drones are coming up, multiple HAPs are coming up, multiple balloons are coming up, multiple LEO satellites are coming up, and apart from that, people are trying to use some pseudo satellites, like everybody can keep a small satellite and communicate. So when we are getting so many devices into the network, along with the existing devices what are there on the terrestrial network, the number of bits which are moving to the cloud or handling it is very difficult, right? So under that scenario, what we try to do is, we try to do some analytics on top of it and take the information what is required and remove all the bits, right? See, for example, you take a good example is a JEE exam. There might be 2 lakhs people who might be writing, you are selecting some 10,000 or 20,000. Similarly, what we try to do is, from the whole set of data, we try to extract the data which has information, and we reject the data which doesn't have information. So we call it as analytics. First step is we do analytics on the data. On the huge data, we call it as big data analytics. And we try to get the information out of it. So what we do, we first examine the raw data. First step is you see what are the data available to us, what is the data coming into the system, and then we draw some conclusion. Okay, this data is useful, this is not useful, this is useful, this is not useful. We try to draw some conclusion on it, which means that we should know what is important to us. See, the data, what is important to us, might not be useful to you, right? So based on because the data is so huge, there might be a lot of information in it, I might be looking for only temperature, somebody might be looking for humidity, somebody might be looking for some other part, and so on. So you examine the data and pick up what is required. So based on that, you draw a conclusion, this type of data is useful for me, right? And then there is what we call it as lake and stream. This is of prime importance, because lake and stream will tell us whether we want to store the information or just look at it on the live data and say whether it is required or not. So lake means you put it in a pond type of thing. You keep it in a pond, store it, and do processing out. Stream means live data streaming. So data is coming on, in that data you pick up whatever you want. So what we do is we segregate, or we try to either store it or use live data and stream it out. Okay, most of the cases live streaming is sufficient. For example, you are monitoring a place by a camera. So you get live stream of data and you don't need it. You want to know when there is an event occurs, right? So there should be some machine which says that, okay, now the event has occurred. It will be keep on watching it, as and when some event occurs, it only tells us, and then we capture the data, right? Like some police, he is standing there observing the traffic. Whenever something is going wrong, he'll go and act, right? The other one is you keep the data set and look it afterwards, called as a lake. So we have a data lake corresponds to a huge storage. You need a lot of storage over there. You need a big memory, cloud memories or something you try to use, because the data is coming in. You have to use it for storing purpose. So that is one important thing. And when we store it, we have a lot of information. We have historic information, because you have stored it. You know yesterday what happened, day before yesterday what happened, and previous day what happened, and so on. Because you have the data. For example, if you try to see the weather over a year, last year by this time the temperature was 24 degrees, so I can predict, so tomorrow the temperature might be 26, right? So the historical data is available to us. Based on that, we can estimate what can be tomorrow and so on, right? And the next thing is you can do the job at ease. It is not that you have tied up with time. So once the data is there, I can use it for a lot of application, like predicting a linear regression. I can draw a line to what can be tomorrow, or what can be, all these things, predictions can be done on the historical data. Whereas the data stream, it is a live data. Live streaming is coming in. So you cannot really say that prediction is easy, right? But for handling the live streaming, you need some fast computers to do. You need parallelism over there. Take the data, compare it, and then leave it. Take the data, compare it, and leave it, right? You cannot do bit by bit, because the data are coming at faster rate. If I start doing bit by bit, it takes longer time. So there is a pros and cons for everything. Real data is very difficult to handle. Storage data, it is easy to handle, right? Because it is not going to vanish. It will be there for some time. I can do a lot of things. Whereas real data, it vanishes. It will not have, it will be there after some time to do some analytic on top. You need to do much faster, where you have to use parallelly, you have to do things and send it out, right? So this is for storage, long-term historical data, easy to use. And whereas if you try to see the data streaming, real-time data, parallel analysis, and difficult to handle it, right? So in most of the cases, what we try to do is we do clustering. Clustering is an easy job for us. For example, you have a big sentence. I can bring all capital letters to one side and small letters. That is what grouping is. Clustering is nothing but grouping. Okay? It might be useful, it might not be useful, different thing. The example of clustering is you bring all one type of data to one set and other type to other set and so on, so that you can segregate it, and people whoever wants it, that group can use it. Or suppose, for example, consonants and vowels. Vowels, you can take it, and so in a line, how many vowels are there or consonants are there, you can take. That is one example of clustering, grouping all of same feather at one place. right? Or you can see, I want in a paper you have written, I want to find how many letter alphabets words are there, or 3 alphabet words are there, or total words how many are there, I can analyze it, right? So based on that also I can get some information, because I can say evenly the words are distributed, or you are trying to use only one set of words for your paper, how many times it has been repeated in your paper, I can analyze everything, right? It gives me some type of information if I am trying to look into that, right? So the clustering is one of the good example of finding a group from the other groups, right? And most of the cases when we have large data, we try to use clusters. We bring all one type of data to one set, other type of data to one set, and so on, so that it is easy for us to handle it and remove the other groups which I am not interested in. Right? So this is a good example of a clustering. I have students of NIT, and of that, I try to find out who belong to the same state, like how many of them are from Andhra Pradesh, how many of them from Telangana, how many of them are from Karnataka, how many from Tamil Nadu and all. From the largest set, I am trying to find out, and from that state, I can find out how many are interested in software tools, so that I can get the information, right? So now I have a full-fledged information of the data available. So this is only an example, but you can apply to anything from the drones and all. Lot of communication is coming. I can segregate the data which is coming from drone, which is coming from household, which is coming from mobile, which is coming from lands, and so on. I can segregate them, so that I can only look at aerial drones data, not other data, because that doesn't belong to me, right? So first you have to pick up a group or a cluster of the data what you are trying to look at from the complete data pool, right? And that you have to do, you don't have a liberty to do whenever you want it, because the data is coming in live, and how much memory you have to store it, for how long you can store it, and from that time you have to pull out your interest, okay? And these are all, like, if you try to look from the practicality there, you hardly have time to do that, right? Because the live data are coming in heavily, and your RAM or memory or something is getting filled up. Once it is filled up, when the next data comes, the first data has to go out. When the second data set is coming, the second data set has to go out, right? Because your capacity is that much only. You don't have, like, for example, you have a jug of water. If you remove one glass of water, you can pour one glass of water, right? If you don't remove it, another glass will be spilled over. The new data will be spilled over. You don't have the information about it, right? So the discharge and the coming in has to match for you to have some time on doing the processing, right? So this is one important thing which you have to keep in mind. Try to find out you do some segregation so that you pick up your information and you can store that information. Rest of things you can empty it so that you have space for the new incoming data sets. So now, when the data is coming, the data can be of different types. It can be either a structured data or it can be unstructured. What is the structured and unstructured data? For example, when you join your college, there might be a form which you have to fill up in the online, which is name, roll number, your date of birth, or your program, or your male or female. There is a set which you have to fill it up, right? That is what we call it as structured data. There are fields are structured, they have been written very clearly, and you have to put those data only, right? In the date of birth, you cannot write some words. You have to be some numbers. In your name, there is some 20 alphabets you can put in. You cannot write a sentence over there, right? So everything is structured over there. So if you try to look the data when you keep it, it goes into a database, right? Each user will, or each student will put the data, it goes into a database. And the database, what we are trying to look is a structured database. It has number of columns are same for every student, right? In a database, if you try to open it in an Excel sheet and see, the name, place, and the date of birth, and the gender and all, they are well written in a column wise. It will be appearing in your Excel sheet. That is what we call it as structured data. Right? Unstructured is, you don't have anything like structure and all. You can put your photograph, you can put your signature, you can put your name, wherever you want, and you can send it. And if you open an Excel sheet, you will not find anything. You will not be able to sort it out also. I want to sort out by date of birth, I will not be able to do, because there is no column indicating date of birth. Right? So there is an unstructured way of writing it and a structured way. So when you go to the structured and unstructured ways, we have a lot of problems in that case, where in structured you have a RDBMS software or something like that, where you can have the data written very well into the database. Right? If you are good in database structures and all, you have a rational database management system, RDBMS we call it. So you can open the RDBMS, everything will be in a structured format in it. Right? So these type of RDBMS and all is not suitable for storing the unstructured data. Right? We need a different type of database to handle such type of thing. And one good example is MongoDB. You heard about MongoDB? So MongoDB is one database where you can use it for unstructured database. Okay? The unstructured can be text, audio, video, photograph, image, whatever it is. Right? I hope it is good up till here. Lot of data is coming, and from that data we are trying to pick up what is, clustering it into whatever format we want, and we can use it as a real-time or data lake. We can keep it in a lake and remove it whenever we want, or we can process online and send it out also. Right? And this data can be either in a structured way or unstructured way. In a structured way, the formats are fixed, and the rational databases are good enough to handle that. When it comes to unstructured, there is no fixed one. Data is variable. Text, it can be text, it can be image, it can be video, it can be a music, whatever it is. And any format it can take, and anywhere it can sit. So what are the sources of unstructured data? If you try to look into the internet, there are billions of bits content shared on WhatsApp. So what you will write? Some people will write, hello, how are you? Some people write, doing good. Some people write, hi. Right? For same message, you have different ways to express. Somebody says, hello, Mr. Sai Prakash. Some will say, hi, Sai. Some will say, cool, Sai. So there are different ways, right? Because the text, what we try to use in the social media platforms, have changed the structured format. People use codes, people use emojis, people use a lot of stuff. Right? It is not one way of telling. See, people write namaskar, but now symbol has come up. People put this one, they will not write namaskar also. Right? So there, it can be an image, it can be a picture, or it can be a word, text, or whatever it is, they have their own way of doing it. Some will put GIF files. I think you know GIF files, right? There will be continuously a little bit motion in it. Okay? So the namaskar will be swinging like this. Okay? So the data what we are trying to look from the internet has no structure. Right? So majority of the things, if you try to see, the social media platforms like Facebook, Twitter, WhatsApp, a lot of things have come, X platform and all. People have their own language in representing it. They have the same thing they can represent it in text, same thing in image, same thing in video, same thing in GIF file, whatever it is, they can able to do it. And know how to store them into a database and retrieve them whenever we want. Right? So we have to move towards a non-structural databases and try to look into that. Right? So this is about the text. So don't assume that text is the structured language. Earlier it was, but now it is not. Because whenever we say text, this is the best thing, we can handle it. Right? That is there with a lot of people impression. Text means, oh, now I can handle it easily. But it is not that easy, because you have to capture the emotion of the text and then analyze it. Right? So now we have to dig it. Right? The text, we have to dig it and see whether it is good or bad. For example, you have somebody will express some news in the Twitter, and then you'll see that people put comments, going on putting comments, 1,000 comments, 2,000 comments, 3,000 comments, and so on. So now, if you try to look at, there are positive and negative words. Some people try to praise it, some people like to abuse it. Right? That's what we see. Generally, when a tweet comes, we'll see whether it is a positive or a negative. Right? Some people say that, yeah, very good, thumbs up and all these things. Some people will put thumbs down and start using language with different languages. So there is a positivity in it, negativity in it. And now, if you want to see what is the outcome of that, we have to use a sentiment score, how many positive is there, how many negative is there, and difference of that will tell us whether it is a good tweet or a bad. Right? 1 and 1 will not tell you whether it is good or bad. So if it is greater than 0, it is a positive. If it is less than 0, it is a negative. And if it is equal, it is a neutral tweet. That's how, if you give it to a machine, it calculates it and tells us. Because it is not possible for us to go through all the 2,000, because nowadays people are running in lakhs, not even thousands. Right? For every thing, it comes like 10,000 tweets or 50,000 tweets and all. So it's not quite easy to fill up all those things and see how it is and all. We have to generate an algorithm so that it manages and tell, okay, this is the score and this is the score. You might have seen on the TV screen saying that positive this much, negative this much and all. Right? Because they don't have time to read all the 50,000, 60,000 tweets what they got. So there is a code which runs on it and say, okay, this is positive, this is negative, up and down it will be swinging. Right? I think you might have seen the scores, right? So that will tell you how these things are, opinions and all. Right? So why we have to do this? That's the question, right? Why we have to do all these things and all. This is not so much important to these fake news and all, but for the communication networks, it is a primary job. We have to dig it out and find out, because we have to make a decision on top of it. Right? It is not like knowing it and leaving it. We have to do some corrective measures or decision on top of it so that the system runs smoothly. Right? Otherwise, the drone, if it doesn't get an instruction within a well-defined time, it doesn't know what to do. Right? Or if it doesn't control it, it might hit some other drone. So there is a very possibility that the drones have to be controlled very carefully, and the information has to be given to the drones in the appropriate time with a minimum latency, so that they all follow into one stream. So now we have to extract information from the data lake. When the data is coming and falling into the lake, we have to get the information as fast as possible, because the lake will get filled up and it will be overflowing it. Right? So now the algorithms what we are trying to look at has to do this job. Right? So now the data coming from various devices, whether it is a drone or it is from a base station or it is from a mobile or whatever it is a data. That is Internet of Thing, the mobile is a thing, drone is a thing, everything which has the internet connectivity, right? A network connectivity. So when it is just data is coming in, it is not for curiosity we are trying to look at. It might be curious to look at, but every time we have to handle it correctly so that we can have a positive result on it. Okay, we should not handle it in a different way and land up with a wrong result, right? Because as we are trying to look from the point of view, for example, if you take a jumbo aeroplane, there will be around more than 10,000 sensors working on it. Okay, So if you are trying from that end and the number of text what you are trying to look at is more than tens of thousands, and that data is coming in, so I have to prioritize on data which I have to look immediately, and some can be delayed, right? For example, I have to continuously see the turbines are moving properly, and there is a engine temperatures are maintained properly, and there is the speed of the plane is maintained properly. All these things have to be monitored prior to the passenger request for some music or something. He might be interested in some movie, he might put it, and that need not be prioritized, right? There are some things which have to be prioritized, like the engine and so on, so that in case if something happens, I have to react to it, whereas here it can be delayed by few minutes or something like that. So this is prime important. The data might be curious only. From that, I have to find out the levels of priority and allocate the resources for that. Okay. So now, if you try to look at the traditional management systems, what we have, they are not ready for it, and we need something, a different type of databases to look into that. As I told you, mostly nowadays unstructured type of database we are trying to use. So as I told you, all the data is not same. They have to be categorized. They have to be separated. I have interest in some type of data. Someone is interested in some other data, and so on. For example, I am trying to do the drone flight control. I need only that much. And he is interested in drone internal part management. He is only interested in the internal part temperature management. And you are interested only into what is the temperature of the drone when it is flying. You will take that much only, right? And he is interested only to know whether it is moving in the right direction or not. He will know that. So each one have their own thing to search it out from the maximum data. So that we have to do some type of categorization and then try to move it. And we have now two important things. The data, what we are trying to get, it can be something like in motion or in rest, right? So for example, when you are trying to monitor some area by a drone, then you cannot say that camera can be switched on after 1 minute. It has to be continuously on. Whereas when I am trying to find out the humidity at a location, and if I want to monitor it after some distance, I can monitor humidity again. I need not have to monitor humidity continuously. Because even if I monitor like this place and that place, I know there will not be much change. Temperature, it will not be much change. For 100 meters, the temperature change will not be that much, right? The humidity might not change, might not be that much. So every 100 meters, I can start measuring the temperature and humidity, whereas video, I have to keep it on to get a live data what is happening within the 100 meters also, right? So there are some data sets which are typically important, which can be periodic. Some things might be non-periodic also, and so on. So you can categorize it like that, and you can take it. So now when we come to the drones generate both structured and unstructured data also. It is not that the drones are only structured data. We have both types of data available in the drones. So when we have that, you please remember that the structured data is easy to analyze. For example, I have a student database. It is easy to find out how many are born in year 1990. I can just put a command and it gives me the total list. Or if I want to find out how many boys and how many girls, with one command I can get it, right? If I want to find out how many people are there from this state, I can easily find it. Because they are all lying in a structured format. Only thing is one command is sufficient to search one column. I need not have to search the complete file, right? But in case of unstructured, it needs some type of mathematics or analytics or some type of language to, or some type of intelligence to find out all photographs, all the signatures, all names written in different hand styles and all, and then to it. It is not that easy. right? So now the problem of that is we will handle all the non-structured data using machine learning, right? And coming to the communication system, if you try to see, with the communication network in place, for example, you have a terrestrial network. We call terrestrial networks where on the ground all the networks are integrated. And right now we have internet as the example of that. And now we have drones network, where it is, let us assume that it is a totally new network. We have not connected to ground. There is a separate network running parallelly, and they connect to internet. There is a separate network like satellites. They are connected separately to ground station. They are separate. And if the ground station and the base station are connected, then there is interconnectivity. Let us assume that they are separate networks. And now each network has their own requirements. For example, you take drone network, they need some type of bandwidth for communicating among the drones. If you take satellite, they have a different type of communication requirement for the, see, satellite to satellite communications and all, they need few kilobytes of data is sufficient to communicate. Whereas if you take a terrestrial network, we need tens of MBs to connect. You are not happy with 1 MB, 2 MB, you will need 10 MB or 20 MB to communicate. And satellite, it is not like that. They are not watching movies, right? Whereas you are watching movie. So you need a high data rate, bandwidth for you. But the satellites are not interested in watching movies or watching some WhatsApp. They don't talk on WhatsApp or not, right? They have a different requirement totally. And similarly, drones, they have a different requirement based on the application. So when we have a different requirements for the different networks, and if you're trying to tie all these things, there should be a mechanism to allocate whatever they want, right? There should be some mechanism where if you ask some sweet, I have to give it. If you ask some mixture, I have to give it. If you ask something else, I have to give it, and so on. Okay? So I have an intelligence. So I know looking at him, he needs sweet. And he needs some type of mixture or something. And he needs something else. He needs some rice. And I know that he needs the idli. So it is there in my mind, so I can use it. So now we are training something like that and keeping it live so that when a request comes, it says, okay, you take this, you take this, you take it. So this is the process what we are trying to look at. We are trying to train a system with some mechanism so that it can predict what the other wants it. So that's what we are trying to look from the communication point of view. We are trying to make a machine learning algorithm for the communication purpose. Based on the parameters, we allocate the requirements like, okay, terrestrial network, they need higher bandwidth. Whereas drone network, they need lower latency. Satellite network needs latency is very large for them. So they are not power, they are only looking at power as a requirement because they have to be charged by solar systems. And the sun will be there only for 12 hours or something like that, right? So each network have their own requirements, and based on that, this machine which has been trained has to allocate the requirements of them, right? So now we try to come up with those solutions. And now when we have that, the data has to be classified either it is in transit or it is in store, right? So when you are trying to allocate the resource, and if the resource is not sufficient to get the live data, then it is of no use, right? So most of these algorithms, what we try to do is we try to use fair distribution. I want everybody to get a share. So for example, let us take a good example of that. I have 150 kilobytes of resource with me, and for a voice call, I need 64 kbps, right? So there are 6 people, so 3 voice calls are possible, but I don't have a resource. I have only 150, and each one requires 64. So the total will be 128 is the maximum. So if I now do the equal distribution, like if I have 150 divided by 6, if I give them, none of you will be able to talk, right? So the question of fair distribution or some weighted distributions are easy to say and implement, but intelligence is not there, right? So if an intelligent algorithm is there, I will see that at least some of the bandwidth is used carefully instead of wasting it. Okay? So I'll pick up which two I have to give it. Out of the three, I can give only 2 calls. So I have to make a decision which one is important, prioritize, and for them I have to allocate it. For the least priority call, I can say wait until this is complete, I can transfer it. Right? So building up intelligence is a prime job of any machine learning algorithm. So when we are trying to look from the machine learning algorithm, data is given, the data, the results what we can get is descriptive, or it can be diagnostic, or it can be okay, descriptive, diagnostic, predictive, or prescriptive. So the first one is descriptive. What does it say? What it happens, what is happening it can tell you, right? Or either the data is presently happening, or it has happened, or it is going to happen. Right? The description can say that, okay, it is happening now, or it has happened yesterday, or it will happen tomorrow. That much I can say from the data what I got. That is what descriptive. Diagnostic is see, when you go to a doctor, right, you describe, I am having this type of problem and all, then he'll say you go through this test, you diagnose and come back, seeing the results, he says, okay, this can be happening, or this has happened and all, and he give prescription for that. Sorry? Why? So the diagnostics is a way to look into the data carefully and try to find out, okay, diagnostics, as he said, it is a why, question is why, and to find out deeper into it, why, what had caused actually to happen, right? And then predictive is, we can say, based on the past history, this will come out like this, or this might happen. It is not that it is going to happen. It can happen. Like I told you, we have a historical data for last 10 years. 10 years on March 10th, the temperature is this much, so tomorrow it can be this much. Right? So the doctor has an experience like, okay, this type of symptoms I have seen in these cases, so he says that. Right? And then comes the prescriptive. Like what should be taken care so that the things will not go bad. Okay? So these are the 4 types of results when we try to use the data analytics on the data what we are trying to get. So it can be of either of a descriptive nature, or of diagnostic nature, or it can be a predictive nature, or it can be prescriptive nature. So now the machine learning. So before going to machine learning, let me just give you an overview of some of the terminologies which are popularly used in the machine learning. So we have, the machine learning is, we are artificially creating some knowledge to the machine. So this comes under a broader class of artificial intelligence. Right? We have a broader description of what we call it as artificial intelligence, or a knowledge-based systems and all. So out of that, we are trying to look only to the extent where this artificial intelligence can be given to machine. Okay, we are only trying to look into a subset of artificial intelligence where we can apply that directly to machine, and machine can do some jobs. So most of the machines to machine communications, we use this type of information or intelligence. And if we want to know much deeper into it, we have deep learning into it. Okay. To know finer details and more into that system, we get into deep learning. Right? So you don't get confused between deep learning, machine learning, artificial intelligence, they are all subsets only. Okay? If you take a bigger set, subset is ML, and from that subset, still smaller subset is DL, and natural language, NL, NN, and all these things will come in. Okay, so we are not confused with these words, whether you can loosely use ML, DL, AI, and all, as far as you know the difference between them, right? So now, when we are trying to look from this point of view, so when we are trying to look from this point, machine learning from the communication point of view, we want to make more sense from the data what we got. We want more information from the data what we are getting. From the drone, if we are getting it, we should know what of the drone, what is the velocity of the drone, which direction it is moving, what can be the next move of the drone, whether the fans of the drone are moving properly or not, whether there is any problem with the heat of the drone, or whether its job is to scan something image, whether the camera is working good or not. This information we want it. So from those information, I am trying to look into the flight control, moving the drone from one end. I have to pick up that data set from it. The other people will pick up their own, like fans are moving properly or not. Some pilot will be there, he'll be looking after those things, right? So there is a track engineer who will be looking after track. There is a pilot who will be trying to increase the speed and decrease the speed of the drone to go up into the required altitude. Otherwise, it might come down, it may move up and all, or it might be moving away from the track. So these are all the things we have to do it. So there are different clusters coming up of that. And we have to see from the data set whether it is proper or not. The data what is generated is good or bad, we have to decide. So there might be 4 fans which are moving and 3 are moving and 1 is not moving. Automatically it has to be picked up from the cluster what it is, right? So we need some efficient tools and algorithm to find out data, more information. From the data, we have to somehow extract a lot of information from that. So now, if you try to look from a bigger picture, ML is a subgroup of AI. Okay? It is a subset, we call it a subset of AI. And it is concerned with any process where the computer needs to receive a set of data that is processed to help perform a task more efficiently. Okay? Because what happens with human beings, after looking for some time, we loses the information. And whatever data comes, we will assume that it is same. Right? But the machine cannot have such type of lags and leads where a human being might be having it. Right? So we want the ML to be processed such that there should be some process which is trying to process the information and get the information out of it, right? And it should be more efficient. So we have 2 categories of that. One is supervised learning and other is unsupervised learning. Any questions? So we group the machine learning into 2 parts. One is supervised and other is unsupervised. There are other groupings also. Let us stop over there because there are a lot of groups coming up nowadays, like hybrid groups and all these things. So in supervised learning, if you try to see, the machine is trained with input to which there is a known correct answer. For example, when you are small, we'll say that read 2 into 1 is 2, 2 into 2 is 4, 2 into 3 is 6, 10 times or 20 times or 30 times, until when I show 2 into 2, you will say 2 into 2 is 4. Right? That is what training is. Training is you go on giving the same data until it gives the correct answer. Then you say the machine is ready and trained. And now if you give an input, it says this is out. Okay? So the primary job in supervised learning is to take a stick, sit with the child, read until it gets it, and then now you can say that it is perfect, it can do the job. Right? And supervised learning is efficient if we have a large training set. If the training set is larger, instead of 10 times, 20 times we make it you read. 30 times you will not make a mistake, right? So if the data sets are large, right? If you have a larger data set, the machine will get used to the data sets and then when you give a new data, it can predict more accurately. Right? The accuracy depends on how much data set you have trained the machine for that. Okay? So most of the cases we'll say 80% data set and 20% actual data and all. If it is 90-10, you get more accuracy. Right? If you say 95 and 5, still more accuracy. If you reduce it to 70, you can see the accuracy decreases. If you bring it to 50-50, still the accuracy goes back. Right? So always the data set has to be given 100% to the machine, so that whenever you give a data, it will say right answer. Your outcome accuracy will be 100%. Right? It is not that the algorithm is giving you efficiency. You have trained the algorithm such a way to give accuracy. Okay? So I have seen most of the people saying that I am getting accuracy of 99, 98, 97 and all. They think that they have done very good in machine learning algorithms and all. It is not the accuracy of that. Because of 80% you are getting that. If you reduce that to 70 and 30, you will not get that accuracy. Right? So please remember that the outcome, if they say that I have 90% efficiency outcome and all, it is because you have trained the machine so good that it is able to predict it properly. Okay? So your analysis has to be in that direction. Regression is another way training the machine with measured values so that the machine can predict the outcomes properly. So if you have some past history of it, train the data with it, like last 10 days it happened like that, tomorrow it can happen like that. Last 1,000 days it happened like that, it can predict more accurately. So you are fitting a regression over there, linear regression or some type of regression, so that the outcome will be predicted properly. So this is the main thing of machine learning. Machine learning is you make the machine learn as much as information you have, so that it can. For example, let me tell you one thing. Suppose I have trained the machine with my data. Like every day I come at 9, go at 5:30, I teach something and I do some job and go. So it knows my data perfectly. So tomorrow if I ask him at this time what I'll do, it says that tomorrow there is no class at this time, you will do some office work or something. But if I go out to a hospital, it doesn't know that I go hospital at that time, it predict wrong. And that's how you can see the Google Maps and all. It says that you take this route and you'll end up in C or somewhere. Right? Because that point is not trained to the Google Map content. Right? If that point has been trained perfectly, it will not lead to that point. There are a lot of points in the map which have been not identified yet. See, most of the cases when you map, they'll say that you insert your data over there. But generally we don't do it. Right? If you train that one, automatically it goes to the same place. If it doesn't know the information, even though you are trained, it goes to the closest one and says this is the point. Right? With some accuracy it has predicted. It is not 100%, right? So now, unsupervised. This is a very good example. Like when you try to look from the unsupervised machine learning, you are not going to train the machine with that. We are trying to look at small deviations in multiple dimensions. Right? What is the change yesterday and today? What is the change on January 1st and January 2nd? So you try to look for the changes what is occurred. It is not that you have trained something and you are trying to predict. You are trying to look for the deviations in multiple dimensions, and then you are obtaining after computing some iterations and all, you conclude with some answer. And this is mostly, we do it in unstructured data formats. If we don't know the data, today I got an image, tomorrow I got a text, day after tomorrow I got some video, day after tomorrow something else has come. So it is very difficult to analyze. The machine cannot know what it is. So it only tries to look at what are the changes you are getting it over a period, and then it tries to predict. Right? So mostly if you try to see, for example, there is, let me take the help of you. He always put good morning in the WhatsApp message. When he gets up, he'll put good morning in the group and he'll switch it off. So it is something like a structured data. So day after tomorrow, if you ask tomorrow what he'll give, good morning only he'll give. Right? So today he has kept good morning. Tomorrow he has put some namaskar emoji over there. The day after tomorrow he has kept some sign like some drawing he has made, good morning, hi or something, and he kept it, and so on. If he is wearing that one, then he tries to observe what are the changes he's doing. Today and tomorrow he has kept like this, tomorrow and day after tomorrow he has kept like this. So he based on that he will try to predict it, right? It is not on the training set. Okay. So there is, in supervised learning, there is not a good or bad answer known in advance. We don't know whether it is right or wrong. We will just, based on the data sets, we will try to put it, okay, this is good and this is bad. It is the variation from a group behavior that allows the computer to learn that something is different, right? So in the group, if you try to find out, there might be some people who are using text, some might be using emojis, some might be using GIFs, some might be using videos, some might be using some other content, written content, scanned content and all, right? So it can only say that in this group, tomorrow there might be 5 text messages, 5 videos and 6 videos and so on, right? So now, I think I'll stop over here. We are almost close to 3:30, and we move on to the lab session, so that some 3 or 4 routines are there, which will give, first try to run it on your laptop. Okay, we'll give the codes of the routines, like a random forest. Sorry? Sir? Okay, gradient descent and? Okay, so decision tree algorithm, and gradient algorithm and the random forest. These 3 will give you, and once you run the codes and all, if you are comfortable, we will give you a data set, and we will see how to allocate resources from the data set based on the data sets, right? So we'll just take 10 minutes break and we'll come back and we'll start working on that. Okay.